Alright, this is a video for the last part, the jaw handle. And we're gonna start from the major steps. So basically, this is a model based on the jaw. Okay, so we're gonna cut some of the volume from that jaw. Then we will make multiple datums and cross sections. Then we will make a big swept. Yeah, so the lower portion is a swept, and the top portion is some of the parts from that jaw. Okay, so first thing you want to do is open your jaw part. Okay, and once you have that on screen, you probably want to clean up this part navigator a little bit. So you can select all the features in this navigator. Maybe you can skip the first one, but it doesn't matter. So you want to see that datum coordinate system all the time. You can leave that alone. Once you select all the features, you want to right click and find this feature group. So just type in a name, say this is the jaw, okay, and say okay. So all the steps we make, we use to make the jaw are in this folder of the group. Now that will give us a cleaner navigator. Then we're gonna start the first sketch. Again, that's on the XY plane. So sketch on XY plane. Then we want to get some information from the jaw, and let's show. Actually, we don't need the solid on the screen. We just need the very first sketch of the jaw. So that'll be the sketch, and we need to project some curves from that sketch. So let's find the project curve, and you want a single curve instead of the whole sketch. So what we need is 3 curves from the sketch. So this one, the top, and the blade. Okay, now we're done with the first sketch. We can just hide it. Okay, and all right, look at the dimension here. First, we need to close up this from this blade to the very tip. Okay, then we have a horizontal. Let's start from the 3-point arc. Okay, so 3-point arc from the projected curve. That's the end point. Then somewhere here, doesn't matter, as long as you make this tangent. Okay, then we can draw this bottom line here. That's a fillet. So that's a fillet. So we're gonna do that the last. And by the way, it's not at the end of this projected curve. So you want to snap to the this point on curve. Okay. All right, now that's the horizontal reference line. So from this point to point on curve, and it's a little bit tilted. So you want to make this horizontal and turn that to reference. Now we can add dimensions. Let's make this a little bit bigger dimension. And so 0.4 from the top point to this line. Okay, so 0.4 inch. And from this point to that point is 0.75. So that's actually the length of this line. So we can just say 0.75, and we have an angle dimension here. That's 40 degrees, and I think we're fully constrained. We can finish the fillets, and that's 0.15. Hit enter, click on the point. Alright, so still fully constrained, which is good. All right, next step, we need to extrude this. And since those curves are not in a closed loop, you see this is sticking out here. And if you can trim this off, but once you trim this off, this line will lose association to your first sketch. That means you probably get under constrained sketch. So I would just leave this alone and try to extrude this from within this sketch, or you can finish the sketch and extrude. So now you can't just click on the sketch because that's not a closed loop. So what you want to do is you want to change that to region boundary curve. Okay, deselect everything first, and that's your area you want to extrude. And that's a symmetric value. It's not here, so it doesn't matter actually. Now you want to show the solid, and as long as this extrusion is thicker than your jaw, that'll be fine. And you can say what we need is intersect, and okay. And notice the ladder here. That's not quite good. Okay, so actually on this piece there's no ladder. What we need to do is we can suppress this ladder and pretty much suppress all the cosmetic aesthetic features. So that'll give us a clean bottom part of this. And also on the real thing, there's only blade on one side. The other side is kind of a chopping board. So we need to find the chamfer and suppress that. Now this will be a flat surface which will accept that blade on top of it. Okay, so we're done for this cutting portion, and it doesn't like it because we suppressed some features, but that's fine. Okay. And never do that. Okay, so that fixed that problem. Okay, let's get rid of those things first. Suppress, extrude, okay, and also the chamfer. All right, next. So next is going to be a sketch for the two guidelines, those two on the sides, and also we have one line in the middle for the datums for the sketch for the swept. So first we can hide the solid, and then we need to project one arc here from the sketch. So first let's build a sketch on XY plane again, then project a curve. Why do we need that? Because we want this guide curve to be tangent to this sketch. So project this curve. All right, that's enough. So we can hide the sketch and turn to reference. Okay, now we're gonna start this sketch. As you can see, we can start from the horizontal line on the top. That's the reference line, and dimension it. Need to zoom in here. 0.8. So 0.8 inch. Okay, and you can trim this off if you want to. And also we have dimension for the length of this line, the right point to y-axis, that's 0.6 inch. Okay, and now we can start this shape. We need to start from the middle. Okay, if you see those parallel. Alright, so we have a line in the middle. That's like the direction of the handle. And we'll give this a dimension, XY dimension. So the vertical dimension is 4.7 inches. And then horizontal dimension is 0.6 from y-axis. Okay, now we're gonna start on the guide curve. From the left side, that's one arc and one straight line. So 3-point arc from the top, and also this should be tangent to the projected curve. Then we just start a straight line, and you want this to be parallel to this line here. And as to the right side, that's a straight line down here, and another straight line that's parallel to the center line here. Okay, then we need the dimensions. For this point to the reference line, 1.4 inch, and distance between those two parallel lines, that's 0.24 inch. Then for the left side, we have from this point to the reference line is 2 inches. And then distance between them is 5/16. Okay, and on the picture it's rounded up, so I added this here. And as you can see, they're constrained. Then we are going to add the two fillets. 6 inches, this corner and this corner. We can put the dimensions to a better location. Alright, so that's all you need to do. The length of those guide curves, it doesn't matter, but you do want them to be longer than the center line here. Okay. Now next step is pretty fantastic. 7 datums, and they're different. Okay, so the first datum plane is actually on this curve, but it's a reference line, so I cannot pick it up, and I didn't bother to change that back to active line. So I used that distance. Then the distance we can just drag, and I can snap to the starting point of this line. That'll give us this datum right on top of this reference line here, which is right at 0.8 inch. That's the dimension we gave to this reference line here, and that's the first datum. So the second one would be a point on curve type. So I'm sorry, the datum on curve. So on this curve, 10%. For the second datum, the third datum is 35%. So apply. Then for the fourth and the fifth, it's gonna be 55%. Then 60%. Then the last two are not percentage. The last two are distance. So the sixth datum is 0.6 inch away from the bottom. So 0.6 inch. And if you like to, you can change the orientation of that datum. Okay. Then last one is 0.3 inches from the bottom of the center line. So that's our 7 datums for the cross sections. Alright, now we can start drafting on those datums. So that's the first datum, and I would like to have something like this. It doesn't matter really the axis, just a preference. Okay, so I'm gonna have this sketch touching on both sides of the guide curve. So what we do is we find the intersection point, and actually that's the starting point of those curves. And you can't pick two curves to find the intersection points, because this command only generates one point each time. So find the curve, apply, find another curve, then apply. Oh, okay. So I have two intersection points now. I can turn them to reference. Okay. Then I have detailed steps here how to draw this sketch quick. So I'll just do something like this. A rectangle which has a height of 0.5 inch, and you want the fillets 0.12 inch, this point and that point. Once you got that, we can use constraint first point on curve. So this point on this curve on this point, and let's do the same for the right side. Okay, so this sketch sits right on the guide curve. Then the last one would be you want this to be symmetric on x-axis. So midpoint for each for either vertical line. You can either pick this point or the sketch origin. That doesn't matter. Okay. And so the outside profile is good. Now we can offset this into a thickness. So you want this to be on tangent curve, because we just want this top, bottom, and the left side. The right side is not tangent to those curves. So once you click here, you would pick those U-shaped curve or C-shaped curve. You want this to be inward. Then last step, just trim this off, and this constraint will stay there. Okay, that's good for the first sketch. Then the second one is, I guess, pretty much the same. Yeah, so the same steps, we're gonna build a sketch on this datum. Okay, and find intersection points, apply, and OK. Turn them to reference if you would like to. Reference and reference. Then that's still a rectangle. So rectangle with a height of 0.5 inch. Then the fillet is different. Fillet is 0.2 inch. Oops. Just hit the point. So 0.2 inch. And okay, circle is always counterclockwise. If you pick lines, you should pick like this. Okay, so I prefer hit the corner point, that would be better. Anyway, then constraints vertical line to that point. Okay, I'm using the quick menu constraints. Then vertical line to midpoint. So midpoint for either one. Then we can offset. This one probably not good, because once I trim this off, it's gonna delete that constraint. So better to have this line to be centered on the origin. Then offset, I need to look for a shortcut for that. Offset tangent curve 0.1 inch, the same drill, and trim off. Quick trim is T. Okay. sketch. The next, all right, next it's a little bit different. The left side, we don't have a vertical line anymore. It's just a half circle here. So a sketch on this datum, then I used a circle, but I guess you can use something else. Intersection point, always find the intersection point first, then find that point, reference, this point, reference, a circle. This circle is not on the sketch origin, the center of the circle. So here, doesn't matter, well, it doesn't matter about the dimension here. So 5/8. Okay, then constraint, point on curve. We want the arc to be on this point, and also this is not centered. Okay, as you can see, the center is not on x-axis. So you want the center still on curve, which is a vector on x-axis. So after this, the top and the bottom horizontal line, and you want to find that arrow here. That'll be horizontal. And if something happened like this, you can go back to the circle and pull out the other direction, horizontal. And you can close this off. I did a different way in here. You can draw a vertical line, or you can just close this off. Then turn this to reference. Turn this to vertical. Put this on the point. Okay, and that's all for this outside. We can trim this off. Shortcut is T. Okay. Then offset, no shortcut. Okay, then trim this off. Yeah, let's see, still fully constrained. Okay. All right, now next, it's the same, but with no dimension for the circle. Okay, why no dimension for the circle? Because this time the circle is on the origin to the intersection point. I didn't do that, so I need to go back and find the intersection point. This one here, and the other one, maybe it's here. Okay, and it's not necessarily on the point right now, so you still need to do a point on curve, and don't pick up the center of the point, center of the arc. Okay. All right, now next is the horizontal lines, and oops, okay, horizontal, then close this off, turn this to vertical, put this on the point, now trim, then offset, then trim off. Let's open here, fully constrained, we're good to go. And next, so on datum 5, now it becomes a totally just a circle. So a sketch on this datum, the 5th datum, and that's gonna be a circle. Okay, I'm probably gonna snap to the other sketch, so I'll hide the other stuff, and maybe I need the data to be there. Okay, and okay, intersection point first. And then to reference, then a circle from the center to the point. Let's see, okay. Then the other side, it's remember the distance between those two gaps, they're different. So the other side, you want a vertical line. Okay, it doesn't have to be inside the circle. And put this on to the point. Then we can trim this off. Also the line here. Then you can turn this to reference. Okay, and offset the arc inwards. Okay, close this gap here. So that's all for this sketch. And then the next sketch is on the 6th datum, and which is exactly the same as datum 5, the sketch on datum 5. And also, since those two datums are parallel, okay, so we can simply project inferred curve from the whole sketch on datum 5. And okay, so that's all for datum 6. Then datum 7, it's a little bit different, and it's not touching the guided curves this time. Kind of getting smaller at the tail. So from the origin, okay, a circle that has a diameter of 0.4, then the other circle is 0.1 inch. No, I'm sorry. The other one is just a thickness offset. Okay, so we still need to find one intersection point on the right side. And turn this to reference. Find the vertical line. And point on curve. Now we can trim this off. Okay, and turn this to reference. Again, offset a thickness inwards. Finish. Then close. A lot of work, just repeating the same thing. Okay. All right. Finally, the swept. Okay. So let's turn on the other sketches. Show them. And I don't want to see the datums, so just hide them. Okay, that's pretty good. And swept. Okay. Now 7 sets, 7 sections. We're gonna start from connected curve. Make sure it's on connected curve. And start from here, a new set. Click on the same curve or the thickness. This short line represents the thickness of the metal, the sheet metal. And click on the same portion, like the top or the bottom. If you click the bottom, it's going the other way. So you want to always click on the same side of the same curve. Kind of picky. That's gonna be the 6, 7. Okay, so that's all for the cross section. And the guides. The guides, this time we have 2 guide curve. So it's a little bit different from last time. If you click the first guide curve on the top half, okay, and as you can see, 1 is not good enough. That's going to be weird. And the second one, you do want to click on the same half, the top half. If you click on the bottom half, let's see what happens. Oh, it's actually doesn't matter. And as you can see, the direction of the guide curve it's different. So I do want to make them match each other, just in case some problem happens. And now you can see this place is not good. That's the alignment issue. Okay, so I'm on cubic already. The alignment is by point. It'll match up nicely. If not, that means well, maybe your sketch is not symmetric top and bottom. And I'll say okay here. And so we have done the major work on this already. And the next, there is a little tip at the end of the handle. So we need to find this datum and build another sketch on top of this and extrude something straight out. And that's a ring we're gonna extrude. So first it's gonna be a circle from the sketch origin to exactly the same as a circle on this section. So you can snap to that sketch. Okay, so that's why you don't need a diameter for this circle. Now for the second circle, we can make some concentric. The dimension is okay. The dimension is 7/22. It's the same as the inner diameter of the thread on the screw, if you remember that dimension. Alright, so that's a ring shape. You can just extrude from here, and the distance 0.3 inch, and boolean we want to unite to the swept. Okay, so that's all for the end tip. Then we just need to do some cosmetic stuff. So first is an edge blend for those two edges. Okay, so that'll be 0.6 inch. Okay, and there's a hole here that accepts the jaw. So you need to find that sketch that has a circle there. So it's actually in the group for the jaw, the very first sketch of the jaw. Excuse me. So extrude, then find the circle here. You can use a single curve. Okay, and symmetric, make it longer, and I want subtract from the swept. That'll make a hole there. Then edge blend, extrude. The last piece is the thread. And insert, design feature, thread on this cylindrical face. And the minor diameter is actually the minor diameter of the screw. Then the major diameter, we need to change that to 0.303. That's the major diameter of the screw too. And length, if you keep that at 0.3 inch, the thread will not go all the way through. So I would say just 0.5. Let's go even further. Then the pitch on the the screw is 0.05555, a lot 5 then a 6. So it doesn't matter where you put the 6. Okay, it's actually 5/90, I think. Okay, so let's say okay. Then that's your detailed thread. Okay, so that's actually finished from our this part, and I'm gonna hide the sketch. The last thing is that this part is actually not perfect, or not. Let's say there's still some space you can improve. If you look at here, it's actually thinner than the jaw portion is actually thinner than the sheet metal. And the real thing, they have some kind of welding filler in between. So it's just a simple extrude, but the sketch is kind of messy. You have to project this edge from the swept, then you have to project the bottom edge from the jaw. Then you can extrude and unite them. So it doesn't matter that much because in the fan we'll use the outside face for the fan. That's a 2D shell. Then in between this the jaw portion to the shell, we're gonna use glue. So it doesn't matter what geometry you have in the middle. So I'm just being lazy and skip this part. Okay, if you like to, you can find some kind of a sketch here and fill this in. And if you like to, also you can unite those two pieces into one solid body. Okay, you can tell the difference from the back here. If it's not united, it's gonna be like this. United, ideally it should be a straight line down here. Oh, I guess that's the tolerance or the accuracy in the software, because they're supposed to be tangent, so the iso line should be straight line. So that concludes this part. That's the last part, and next video is going to be the assembly for this project.